Welcome to Cisco HyperFlex video series. This is Software Components Overview. Cisco HyperFlex is a hyperconverged solution that includes both hardware and software as indivisible parts of the system. Let's take a look at the software components in a vSphere-based HyperFlex system, which is the most commonly deployed. One of the main features of HyperFlex is the StoreFS, a distributed log structure file system. Log structure of StoreFS allows it to write information sequentially on the physical hard drives and just uses a system of pointers to the information stored on the hard disks to assemble the pieces into files you have stored on the system. You can imagine the StoreFS index as a ledger of all individual pieces of information stored on the HyperFlex data platform. These pieces, called blocks, create an indexed grid of storage. The StoreFS index uses references to individual blocks to define which blocks in what order consist a file. This operation is great when you have information distributed across the cluster, since the file system ledger always points to the information on the entire infrastructure. As a consequence of how the blocks are referenced, the information can be written to the physical drive sequentially, which means that the drives do not have to look for free space where to put the information. This increases write speeds of spinning drives significantly, since their seek times are much slower than with flash drives. When a file changes, the change is written to storage, and the information which block consists of file is changed, so that it includes the newly written blocks. The old information is then marked for deletion by a background cleaner process, which frees the space for new writes. The file system index is stored in memory of a controller virtual machine. This is a virtual machine which runs on every node of a HyperFlex cluster. It is responsible for finding information in the cluster, logs, caching, compression, and the duplication of data. The physical disks of a node are passed through the hypervisor to the CVM running on that node, which can perform direct reads and writes to the physical drives as well as cache. Physical storage is integrated into the shared data platform and presented as NFS share to the hypervisor. On an hx1 converged node, the CVM reserves 48 GB of RAM for exclusive use and also requires 10.8 GHz of CPU processing non-exclusively. On a 240 converged node, the CVM requires 72 GB of RAM for its exclusive use and the same CPU resources as an hx220 node. The CVM on a large form factor converged node requires 78 GB of RAM for its operation. The CVM is also responsible for HyperFlex cluster management and hosts the HyperFlex Connect management interface, where you can perform most of the management functions in a HyperFlex cluster. hx Connect is the graphical user interface of the HyperFlex. It is an HTML5-based interface accessible by HTTP on the HyperFlex cluster address. It provides you with monitoring capabilities for nodes and HyperFlex utilization. It allows you to create data stores, set up native replication and protection groups, clone virtual machines, and also allows you to upgrade the Cisco HyperFlex components through a graphical interface. It also provides a quick access to the CVM command line, but not all the commands are supported directly in the graphical user interface. What little HyperFlex cluster management cannot be done in hx Connect can be performed in the command line of a CVM using the stcli command. The CVM is an Ubuntu virtual machine, and you can connect to it using SSH. The command line interface provides you with the most detailed information about the state of the HyperFlex cluster. Regular bash expressions are supported, as well as the HyperFlex-specific commands through invocation of stcli command. CVMs also help the IO visor in data operations of the HyperFlex system. The IO visor exists in the hypervisor and is responsible for data distribution. It captures information to be written and sends it to any available converged node for caching. The IO visor is not dependent on the CVM, So if the CVM fails, the IO-visor will still redirect the file system operations to available nodes and is a key component of the HyperFlex resiliency. VAAI is another software system that is utilized in both the CVM and the hypervisor. It is a vSphere functionality which allows direct file system operations to be performed on a data store. This system enables native storage-based snapshots and storage-based clones. Native operation for these functionalities increases their speed significantly, since it uses the StoreFS features like referencing information by pointers instead of relying on the hypervisor exclusively to perform the snapshots and cloning operations. This native file system support optimizes the hypervisor functionalities, making them much more efficient than they would normally be, integrating into the vSphere management through a vCenter plugin, which is installed on HyperFlex installation automatically. This plugin enables the HyperFlex native functionalities to be initiated through the well-known interface. The hypervisor is the hub where the individual software components of HyperFlex interact. It is the environment where the controller VMs are deployed on. The data stores created on the HyperFlex data platform are mounted into the hypervisor, and the IO-visor exists as a VIB in the hypervisor. VAAI is also its functionality. The hypervisor management platform is responsible for high availability and virtual machines in the cluster. The hypervisor is also the component which enables the communication between the hardware and the software. This was Software Components Overview. Thank you for watching.